This is one of our learning objectives in Module 4, define and conduct the basic steps of hypothesis testing. In this course, we'll be using a 6-step hypothesis testing procedure. In your introductory statistics course, you may have used a slightly different procedure. I've seen anywhere from 4-step procedures to 8-step procedures. They're all very similar. Where they differ is usually in how they divide up the steps. When we get to determining the statistical significance, there are two main approaches. One uses the test statistic to look up the p-value. The other looks up a critical value and then determines if the p-value is less than or greater than the alpha level. This week, we'll be using the critical value approach because that's what your textbook uses. Let's start by looking at the 6 steps. These are the 6 steps that we'll be using when we're conducting hypothesis tests by hand in this course. I'll walk through each step in a bit more detail. There'll be a second video that walks through an example. Step 1, identify the populations, comparison distribution, and assumptions. We're going to start by identifying the populations. We do this by reading the research question or the description of the research study and identifying what populations we're comparing. For right now, we'll just be working with means. We'll be comparing the mean of one group to a known population mean. In this step, we can clarify what those populations are. In other words, we state what groups we're comparing. Next, we'll identify the comparison distribution. Since we're working with means right now, this will be a distribution of sample means. Finally, we check assumptions. The assumptions will be different for different tests. Step 2 is to state the null and research hypotheses. We started learning about hypotheses last week. Recall the big picture of inferential statistics. We want to know something about a population. We write hypotheses concerning the population. Then we collect data from a sample. We use that sample data to make an inference back to the population. Hypotheses are always written in terms of population values. The null hypothesis will always include an equality. The research hypothesis always states that there is some difference or change. You can write the hypotheses using symbols, or you can write them out in sentence form. Either way, make sure that you're following these guidelines. Step 3 is to determine the characteristics of the comparison distribution. The comparison distribution is the sampling distribution. In this step, you'll compute the mean and standard deviation of the sampling distribution. For the Z and T tests that we'll be doing this week and in the following weeks, the mean of the sampling distribution will be equal to the hypothesized value of the population mean. The standard deviation of the sampling distribution is the standard error. You'll have a different formula for the standard error depending on what test you're conducting. Step 4 is to determine the critical values. The critical values, also known as cutoffs, are the boundaries beyond which we reject the null hypothesis. In a Z test, these will be values from the Z distribution. Later in the course, we'll cover T tests and F tests. In those cases, these will be values from the T and F distributions. We need a few pieces of information to determine the critical values. First, we need to know which distribution we're using for that test. For example, Z, T, or F. This week, we'll be using Z. The alpha level. This is usually 5% in psychological research. It could be larger for a pilot study or smaller for a study with more serious consequences. If you're not given a different alpha level, assume that it's 5%. And we need to know the direction. We get this from the research hypothesis. If the research hypothesis contains not equal to, then we have a two-tailed test. If it contains less than, we have a left-tailed test. And if it contains greater than, we have a right-tailed test. Here's an example with a Z distribution. Let's say we're conducting a hypothesis test. with a 0.05 alpha level. Note that 0.05 is the same as saying 5%. And assume that these are our hypotheses. The research hypothesis here contains not equal to, so this will be a two-tailed test. Because this is a two-tailed test, we'll have two critical values. One on the right side of the distribution, and one on the left side of the distribution. The 0.05 alpha level is split equally between the two tails, with 0.025 on the right and 0.025 on the left. If you do the math, that means that 0.95 is in the center. Recall, the area under the distribution is 100%, or 1.00. The next step would be to go to the z-table, or to use an interactive z-distribution, such as StatKey, to find the z-values that separate the middle 95% from the outer 5%. And there are separate videos in the course showing you how to do that using both the z-table and StatKey. Step 5, calculate the test statistic. The formula will be different for each type of test. You may notice, though, that many of those formulas follow this pattern. For the Z and T tests that we'll be working with in the next couple of weeks, the test statistic is equal to the sample statistic minus the hypothesized population parameter, and that's the value in your research hypothesis, all divided by the standard error. If you compare this formula to the formula for a z-score, there are some similarities here. The Z and T tests both convert the observed sample statistic to a standardized test statistic. That is what allows us to use the Z and T distributions to determine the statistical significance. And our last step, make a decision. If we go back to our sampling distribution with the critical values marked, if the test statistic falls beyond the critical value, for a two-tailed test, this would mean that it would fall in the left or right tail, we reject the null hypothesis. In these cases, the results are statistically significant and there is evidence of a difference in the population. If the test statistic does not fall in a reject region, for a two-tailed test, that would mean it would fall here in the middle, then we fail to reject the null hypothesis. In these cases, the results are not statistically significant and there is not evidence of a difference in the population. Those are the 6 steps we'll be using when we're conducting hypothesis tests by hand in this course. Next, I recommend that you work through a few examples.